So welcome back. The second lecture on C++ language. And the last discussion we had said about what is an assembler and a compiler. So once again I start from there. An assembler, remember what is an assembler? Assembler, it converts the code that is written in mnemonics. That is the code that is accepted, premature information that is accepted by the user to understand what is happening with the mesh. The example I dealt is move immediate A with some on data. You remember that I write here move immediate A with some data. So I understand that I am moving a data to an register A with the data is 03. So this is a premature information that a user can able to understand. But this need to be understood by a technical person alone. It can't be understood by a higher end normal lay person. So an assembler is a language that converts this mnemonics. I call it as a low level language to binary bits. Low level language to binary bits. So I call this as an assembler. And compiler is a tool that is used to convert the information from the higher level language. It may be Java, it may be any languages. I am taking Java as an example alone. In any languages to a machine accepted code. So that is we have been calling as a compiler. So it is higher level language. I take it as higher level language to binary bits. So this is a compiler. So these two forms the closer interface to a device to activate certain information that has been required by the user at the front end, and what he is requiring that will be done by the device. So how this arrangements will be done? I take a device and let this be a device. Let this be a device, and over the device the sedimentary informations of the code is been written. Sedimentary of the codes will be written. Before explaining this, let me take an example. If I am going to build a building, normally I will go with a lay stone, the core stone, first core stone, and over the core stone this may form a layer. You may remember, you may observe in building in constructing a building, or you may even take the information relevant in building a compound wall too. So we will put a core stone. Over this core stone I will put another brick, and this will go on another row, and over that I will put another brick, and this will go as another row. You may remember. So over I am putting a brick in a single line, and over the that line I will be placing yet another line, and this will reach a specific height that has been required by the user. So this is the first stone, and this is the second stone, this is the third stone, and this is the fourth stone, and we go as like this. So without the first stone I can't able to put the second stone. Without the second stone I can't able to put the third stone. I need the first stone. Without the first stone I can't able to think of the second stone. So I can call it as suppose this is a device, and this device is normally a microprocessor. I use this as a mu. So mu mean it is a micro, P means it is a processor. So it's a device, and the first sedimental information will have a quite compact binding with the device. Quite compact information with the device. Suppose if you have a happening on just look into your computer that you are having. The computer will have many ports. It will have monitor ports, it will have mouse ports, there are multiple ports that have been available in your computers. I call this as hardware ports. So these hardware ports is able to communicate with the rest of the world. And so the first component, scratch component, software component that I am writing is this line that has the closest binding to the device. Normally it will drive the drivers, and that drivers may connect with the hardware component for the further process. So the first layer will have the closest binding, and the second layer will have the contact with the first layer. So the second layer will have the in connection with or binding with the first layer, and the second layer can't be able to get connected with the devices, because if the second layer tries to get connected with the devices, the device can't be able to understand what the second layer says. Just as an equivalent to suppose if a person is he knows Chinese language, and another person who knows only English language, and then there should be a person who can able to interpret the Chinese language to English, and then he can able to speak to this person. And if the person is willing to communicate, he has to interpret to this person, and he can able to return back in Chinese language. So that is the meaning of here. The second layer has to communicate with the first layer, and through the first layer only you can able to communicate with the devices. And if the second layer is willing to get communicated with the devices, then it is not possible, and the device can't able to understand. So these are called as the lower layer codes, or I can call it as the low level codes. So this low level codes can able to communicate with the devices alone, and the language or the interpretation that is being done by the lower layer is not been completely understood by a normal person. It is understood by a technical person, what the layer is communicating with another layer, and what would be the data flow from one layer to another layer. So that will be understood by a technical person. Normally we call this as a firmware language. So normally the person who has been working with this language, we call it as a mainframe engineer. And there are many numerous quantum of openings are available for mainframe engineers, and they work with the low level language. It just looks like a terminal window. They work in that language, and so we call this as a mainframe engineer. And the package of quantum of amount that has been paid for this mainframe engineer is enormous, and very limited persons and very countable persons are available for this type of openings, and there is quite quantum openings are there, but technically equipped persons are not available. So firmware language, we call it as firmware language. So this firmware language only can able to drive the devices to the expectation limit of the user. So if I use a Benz car, and my firmware language is able to drive an ambassador alone, then the Benz car will behave as an ambassador alone. So you can able to understand what is the necessity of a firmware. A highly equipped mainframe engineer is required here. Suppose if I have a Benz car, driver should behave as to drive a Benz car, and if it is should not behave as to drive an ambassador. If it is so like, then the Benz car will behave as an ambassador alone. So this is a mainframe engineering. So after this firmware, the languages that have been developed, I call that language as the higher level language, that we call it as an compiler design. Normally this is an assembler design, and above the assembler then we have the compiler, and that compiler can able to communicate with one compiler to another compiler. Here it can able to communicate with one layer to another layer. That a software can able to communicate with yet another software. So we call this as a compiler. So on the shield I can able to say that it is a device. Over the device I can call it as a firmware. Over the firmware I can call it as a compiler. The firmware I can, in terms of our language, it is called assembler. So over the compiler, and I call it as an user interface. So this is the device. So this will be the normal structure of an operating system. An operating system will be called as like this. There will be 3 rounds. Normally, just to remember as 3 rounds. There will be 3 rounds. we call this as kernel. We call this as kernel, and this is inner shell, and this is outer shell. Inner shell, outer shell. Inner shell and outer shell. The inner shell and outer shell. So this is a kernel. Normally this kernel is a device. So just to compare this with this architecture, so this is kernel and this is device. So this is inner shell, this is firmware or as an assembler. This is an outer shell and this is a compiler. And over the compiler, the user interface is there. So basis on our own device structure, the operating system is, and the structure of operating system is calibrated. So it is a kernel, it represents the device, our own device, or it is just a microprocessor component. And over the microprocessor component, the inner shell is calibrated, and that does the assembler operation. Normally I can call it as a firmware operation also. So over the inner shell, the outer shell is available, and the outer shell, it can able to hold the softwares, whatever the softwares that is. It may be a Microsoft Office, it may be a Java, it may be a VLC player, anything else. The softwares are being written over that, and over the operating the outer shell, the user interface is available. The user interface will give the command, and the outer shell has to respond to that. The outer shell has to communicate with the inner shell. So the outer shell has to communicate with the inner shell, and the inner shell can able to communicate with the outer shell. The outer shell can't able to communicate directly with the kernel. So the inner shell will communicate with the kernel, and the kernel will communicate with the inner shell. So this is a vice versa communication in operating system. You can able to learn if you are quite interested. It has been offered as an active paper in our curriculum, and so you can able to learn the operating system. And hope operating system is an important paper, need to be learned by every circuit oriented programs. So because it deals with devices, how the devices is being operated automatically with the help of the operating system. So this is the structure of the operating system. Hope we can able to learn separately as a paper, and so I am stopping here. And operating system may be classified into two types. So operating system may be classified into two types. One may be a full-fledged operating system. Full-fledged operating system, and this operating system normally we use in our own desktop and in our laptops. You may remember, you will install an operating system. It may be Windows 10, Windows 7, or it may be Linux, it may be any other else, it may be Ubuntu platform, anything else. We will install a full-fledged operating system over there, and over the operating system I can able to install numerous quantum of softwares, application softwares that will be helpful for me to communicate with the devices to get the work to be done. Laptops, you may remember. And there are certain operating system, we call it as a specific. Normally broad name that we given is RTAS, real-time operating system. An operating system that has been available in your mobile phones. We call this as Android phones. It is not a full-fledged operating system. It is a quasi operating system meant for a specific purpose. Suppose if you may remember, there are certain button phones, and the button phones, when you look over it, the software that is the operating system that is inculcated in the button phone is just it can able to call. It can't able to play a VLC player. It can't able to get within a Skype interconnect. But we call that as a specific oriented operating system. It supports for only specific operation. It can't able to go with multiple operations. So we call that operating system as real-time operating system. If you are quite interested, this real-time operating system should have the knowledge requirement of operating system. After the operating system alone, we can able to learn RTAS. So if you are quite interested, you can learn RTAS also. So, and you may remember, this is quite important when device oriented communication is focused. That means the broad branch now emerging is IoT. suppose if a thing is willing to communicate, a pen is willing to communicate with the external world, I have to dump an operating system that the pen need to communicate. Means if a pen is going to communicate a single bit data, what the quantum of operating system that the pen require, that has to give, because it can't able to hold, it can't able to go with a bulky device, I can't able to get a full-fledged operating system over there. So real-time operating system is also vital when device-oriented communication is focused. So once again repeating, operating system is a full-fledged operating system and a specific oriented operating system. So our own structure goes with the backend. So operating system is normally built with C++ language. So operating system is normally written in C language or C++ language. I can call it as a C language, C++ language. A combination of both these are being used to write an operating system, and basically these languages are used to develop the inner shell. So these languages are used to develop the inner shell of the operating system, and so this forms the vital role in writing the operating system. So normally these days the operating system are written either in C language or C++ language, the combination of these, and now Python is also included. So Python, what is the need of Python here? If I want to write a specific oriented operating system for any devices, then Python is most sophisticated or compact enough software to write an operating system for such devices. You may remember a best example, I call it as a Raspberry Pi. The operating system is written in Python. And yet another, you may come across Arduino board. It is not written in Python, but basic C++ language is used over there. But the example I have been taking as Arduino board, it uses not a full-fledged operating system. It is a specific oriented operating system, but Raspberry involves Python as an operating system. So these three languages is predominantly used in constructing operating system. And so if your time permits, I hope you may learn Python in your lower semester, I hope, or you will be learning. I hope you will have learned. And C++ language and C language is the most primitive language. Primitive, it's a basic language, and it is the first language that was being introduced in understanding devices to communicate with the external world or with the user interface. So full-fledged operating system, we are not going into the operating system, we are just learning a language, and on the perspective of operating system, C and C++ language is most vital. So consolidating, a user will communicate with operating system and will communicate with the device. So it's a full-fledged operating system. I will expand as like this. A user will communicate with the outer shell. The outer shell will communicate with the inner shell, and the inner shell will communicate with the kernel, that is a device. Okay, this is the general flow method of an operating system. Suppose if I am using a specific oriented devices as a equivalent to what we called as a mobile phones, then the user, I can call it as an app. My own app will communicate with a firmware, and the firmware will communicate with the device. And this is not a full-fledged operating system, it is a quasi-operating system. It is meant for certain specific operations alone. Suppose if I take an app, a phone call, a phone app is communicating with the firmware, and it will be communicating with the device, and to communicate with the person, and it just uses the phone conversation, that is RF module to communicate with the person. It will not get connected with any other ports for this communication. And this phone call cannot be able to communicate with another app. There are certain apps that the app will get communicated. For example, I take two different apps. One is a phone app that is meant for originating a phone call. It can't be able to communicate with another app. but there are certain apps called as a Skype. This Skype will use multiple apps. It will use the system mic, it will use the system cam, it will use the gallery, etc. So it is communicating with the different apps. So this is not possible in button phones. You remember, this is not possible in button phones because the firmware is not supporting for this kind of operation. But the button phones will have the firmware that is relevant with the phone call. But for the Android phone, I can able to support all these. I hope you understand the relation with what is the device, what is the operating system, and where the utility of C language comes in picture or C++ language comes in picture, and what are the different languages that are being used for building an operating system. I hope you understand. If there is any other relevant doubts, let me know. Thank you.